This is a lesson for section 10.2, which deals with trig functions of any angle. So in the previous chapters, we only dealt with those in quadrant 1, and in the last section, 10.1, we realized that we could find these trig ratios for other functions. Now, the thing that's important with this section is we're going to talk about what's known as a reference angle. And the reference angle is the angle measured from the nearest x-axis. So as you might have noticed in the last video with 10.1 that we were always drawing this angle between the x-axis and the line we got from the points that we were looking at. And those were when we were plotting actual points. In this case, we're going to talk about angles, and essentially we're going to be finding something along the lines of a coterminal angle, but different in the sense that it might not share the same initial side, only the same terminal side, because in this case we're only measuring from the x-axis, whether that be positive or negative. So, for instance, if we want to find the reference angle, and we usually use the Greek letter alpha for each of these angles. So first thing we want to do is draw in the angle that we have. So 135 degrees is halfway between the positive y and the negative x-axis. And if we want to find a reference angle in quadrant 2, what we're going to do is we are going to say, okay, well, technically we're measuring up here from 180. We're measuring backwards from 180. So we are going to take 180 minus 135. So alpha in this case is going to come out to be 45 degrees. So that is our reference angle. And again, this would be essentially the angle we're looking at when we kind of form that triangle with the x-axis. Now, for this next one, 475, the first thing you should notice is that this is greater than 360 degrees. So the first thing we want to even do is to find the coterminal angle. Which in this case, I'll call it theta 2, is going to be 475 minus our 360, which leaves us with a 115 degree angle. So we draw 115, that's rather steep kind of over here, and technically since this is 475, we need to go all the way around and then back to our angle here to get 475 degrees. Now again, we're in quadrant 2, so we're actually going to use that coterminal angle because that's going to be easier for us to deal with. We're going to find alpha to be 180 minus that 115 degrees, and that is going to give us our angle over here. So in this case, alpha comes out to be 65 degrees. So here's our reference angle alpha, and this is going to make some sense once we start going backwards and trying to find angles based on trig ratios. These reference angles are going to be helpful for us. One of the nice things is anytime you're in quadrant 1 to begin with, so theta is 24 degrees, so somewhere about here. Anytime we're in quadrant 1 to begin with, our alpha is also the same angle, 24 degrees, because our nearest x-axis is the positive axis. And so in quadrant 1, we don't really have to do anything to it. We know that we have the same angle. Quadrant 2, we subtract from 180. And now let's look at what happens if we're in quadrant 3. If we're in quadrant 3, for instance, an angle of 240, which would be about here, we want to find, again, the nearest x-axis. So we're not necessarily finding the coterminal angle, we're finding the nearest x-axis, which in this case is still that 180. The difference here is that we're coming forward off of it instead of backwards off of it like we did in quadrant 2. So when we're in quadrant 3, we're going to take our 240 degrees minus the 180 to get our angle. And in this case, we end up with a 60 degree angle as our reference angle. So we went 180 and then we went 60 more to get our total 240. But the reference angle itself is 60. something else I want to do real quick, and I'm just going to write this down as E, and that's what happens if we're in quadrant 4. Suppose that we are given that theta is 300 degrees. Well, if that's the case, then theta is over here, and we would go all the way around to get our 300 degrees. But to find our reference angle, alpha, again, we'd be coming from the positive x-axis. Now the thing to remember here is that the positive x-axis is either 0 or it's 360. So in this case, alpha is going to be 360 minus our 300 degrees, which is a 60-degree angle for our reference angle. So if you're in quadrant 1, you're given your reference angle. If you're in quadrant 2, you're going to have to subtract from 180. If you are in quadrant 3, you are going to have your angle minus 180. And if you are in quadrant 4, you're going to be subtracting from 360. Now, before we had calculators, typically we had to use tables, and that was where reference angles were really helpful. They're also going to be helpful when we start finding inverse trig functions, which you see here below. Before we get too carried away, though, I just want us to remember how to use our calculator, so go ahead and get that out. So again, if you have your calculator, first thing we always want to make sure is we select mode to make sure that we're in degree mode. Mine kind of resets to radians every time, so we do that. We hit second quit to get out of there. And again, I'm just asking you to find sine of 125.7, and we can close the parentheses, and we end up with our ratio. Again, this is giving us our ratio of 0.812. So sine of 125.7 degrees was 0.812. And again, this makes sense because 125 is measured into quadrant 2, and sine is positive in quadrant 2, so that ratio, that decimal, that 0.812, should come out to be a positive value. Now let's take a second and look at secant. We have secant of 318.3 degrees. First of all, 318 is in quadrant 4. Secant is the reciprocal of cosine. Cosine is positive in quadrant 4, so we should end up with a positive number here. So if we were to put this in the calculator, we would have the secant of 318.3. And again, our calculator doesn't have a secant function unless you have a TI-89. So we have to enter this as 1 divided by the cosine of 318.3 degrees. So if we put that in, we have 1 divided by cosine of 318.3, close the parentheses, and we end up with 1.34. We end up with approximately 1.34. Again, we said this should be positive because cosine is positive in quadrant 4, and our angle is in quadrant 4. So with this in mind, we kind of want to figure out how we can work backwards with this. And we want to know, given these ratios or these decimals, how we can work backwards to get those angles when they're not in quadrant 1. And remember, I said when we looked at that original quadrant map, we had 1, 2, 3, and 4, and everything or all were positive in 1, sine was positive in 2, tangent was positive in 3, and cosine was positive in 4. So again, we said that technically each trig function is positive in 2 quadrants. So each trig function is positive in 2 quadrants, and so we're going to get 2 answers for each one of these if we're working backwards. If we're given a ratio, we can go backwards, and we're actually going to find 2 angles that would produce that ratio.